Welcome back. Today we'll take a look at Clippy, and I guess most of you guys who lived in the 90s can remember who Clippy was. And if you don't know, it was basically this annoying guy over here. So he was an assistant in Microsoft Office, I guess going back to the 95-98 era. And he basically helped you with writing or composing letters and formatting documents and stuff like that. But most of the time he was just annoying, and I think most people deactivated that feature, and Microsoft realized that and they removed him eventually. Now he remains pretty iconic and a lot of people can remember him actually, and yeah, I guess that would be the reason why in Rust they have decided to give this tool the name Clippy. So as you can see, the Clippy tool is a collection of lints to analyze your code so you can catch common mistakes and improve your Rust code. So it's actually like Clippy, it gives you hints and suggestions you can then improve your code with. I guess the difference is that this is actually useful. And anyway, so for these exercises the code will fail to compile when there are Clippy warnings. Check Clippy's suggestions from the output to solve the exercise. So let's see, we have over here F32 from the standard library. This is related to floating point numbers of 32 bits. And as you can see in main we have here hard-coded P now, or pi. Now as you can see we have here approximate value of F32 const P found. So instead of hard coding it, we can just here implement that const and pi like that. And as you can see, it's compiling. Now just to make it complete, here we have a radius of 5.00, which is also of floating point 32 bits, and then we basically just calculate the area of the circle. So this is actually the formula, pi times r square, and r here stands for radius. So we have here pi or p times this is for power, so power radius to the power of 2. And then it prints it out like that. So next one. And as you can see, second for loop over caption over option, which is an option. This is type option. This is more readable written as an if-let statement. So instead here, writing a for loop like that, we can just write if-let sum, and we get the value x out of this sum. And x in this case will hold 12. And like that. So as you can see, this is compiling and we have actually covered this. But in short, if-let lets you from, for example, a sum value of type option, it lets you extract this value wrapped inside sum. So x then holds 12, and then you can use x like a normal variable like that. the last one. So possibly missing a comma here. This call to unwrap will always panic. This looks like you are trying to swap value A and value B. Try standard mem swap. This let binding has unit value. Help. Omit the let binding. Back. Resize. Okay. Help. Or you can empty the vector with clear. Emptying a vector with resize. Okay. So the first thing, as you can see, we allow here unused variables and unused assignments, and this is just so that the compiler won't complain if we don't use some of these variables. So in the main function over here we have a variable my option which is of type option, and it holds none. And if my option is none, then my option unwrap, and this doesn't make any sense, because if it is none, this condition is completely useless, because that's actually the task of unwrap. So unwrap checks if there is a value. If there is a sum, then it will unwrap it, and if it's not, then it will panic and return. So that's like that. Over here you can see my array, and we are missing over here a comma, like that, and my empty vector. Now here you can see we have a method resize, and that's this one over here. So it expects two arguments, the new length and a value. Now in the example over here you can see we have a vector with a string slice hello, and then we call resize, we put 3 and world. So as you can see, we want this vector to have a length of 3, and this second argument over here is just if the length is bigger than the vector is right now, than the actual length of the vector, then this will get filled out with this. So in the end we have hello world world, because we want a length of 3, and world just gets filled out. And over here you have a vector 1 2 3 4, and we resize it to 2, and this is just in case it's bigger, but in this case it's actually smaller, because here we have a length of 4 and we want it to have a length of 2, so it will get truncated like that. Okay, but actually to empty a vector, to make this empty, there is a much better way, and it's just by calling my empty vec dot clear, and clear will just make this vector over here empty. Now as you can see, we want to swap these values, so value A should then hold 66 and value B should hold 45. So you can do it like that, I guess, but this isn't the best way, because we are here dealing with memory, and with memory, let me just import this, use from the standard library mem and swap. So then we can use swap over here, and we want to swap, and as you can see it has to be mutable references, value A, oops, mutable like that, value A and reference mutable value B, like that. And then they should have been swapped. And this is a real swap, meaning you're putting this value in this memory location and this value in this memory location, so it gets actually swapped. Okay, let's see. Okay, help consider changing this to be mutable. Of course, this over here has of course to be mutable, because clear expects a mutable variable to a vector, like that. And as you can see, it's compiling and we are done. So that was it, and the last topic of Rustlings will be conversions, and then as you can see only 4 are left, and then we finished. So see you then.